Okay, we said that's one way to search for things. There's a second way to search for things, which is to do breadth first search. So what does breadth first search do? Well, I'm going to make a very simple change. I'm going to, again, store the nodes that I want to explore. I'm going to, in this case, put them in a data structure I call a queue. It's just a list, but it's got the following property. Whereas with a stack, I put new elements at the beginning of the list. With a queue, I put them at the end. It's like lining up for a movie theater, assuming you behave yourself when you line up for a movie theater and don't cut in. So the idea is now, when I see new things to look at, children of a node, I'm going to add them, but I'm going to add them at the end of the queue. Whereas a stack is often called a last in, first out data structure, because the last thing put in is the first thing taken out. A queue is called a first in, first out data structure, or FIFO, because the first thing put in is the first thing taken out. The changes to the code are really simple. We're going to change the name of this data structure to be a queue just to reflect this. But the only changes are how I put them in. And you see it right there. If I'm going to add a left branch, I add it using append because it's a list at the end. And if I got a right branch, I'm going to append it at the end. And I do it in this order of left and then right because I want them to come out in that way. Whereas when I was pushing things, I pushed them right and then left. That's the only change to the code. And if I run it, let's again go over here and I can do breadth first search binary. Again, I'll start with N5 and I'll do find 6. And it says do 528146. So let's look at that. There's my tree. My queue starts off with just the element 5. And again, I look at the first element. It's not what I'm looking for. So I pop it off and I push onto the queue the two children. Looks like just like before. Again, take the first element. 2 is not what I'm looking for. The first element in the queue, I pop that off and I push the children of 2, at the end of the queue. And this now is different. Because again, look at what happens in my code. I go back around and say, look at the first element of the queue. It's 8. Aha! Now I'm exploring at this level. 8's not what I'm looking for, so I'm going to take its children and push them onto the end of the queue, having popped 8 off. And I continue. I take 1. There's nothing to push. That's going to reduce it to 4 and 6. I look at 4. It's not what I'm looking for. I'm going to push its child at the end, which is 6 and 3. I look at the first element, 6, and I'm done. And as I said over here in my code, it says look at 5, 2, 8, 1, 4, 6. So you can see, again, I found the answer, but I did it in a different way. That's really nice.